Hello everyone, welcome to the web learning series. In this video, I am going to explain about the Verilog coding for beginners. In the early days of integrated circuits, engineers had to sit down and physically draw transistors and their connections on papers to design them such that it can be fabricated on silicon. But bigger and complex circuit demanded more engineers, time, and other resources, and soon enough, there was a need to have a better way of designing IC. Verilog was soon developed to simplify the process. Verilog HDL modeling language support four kinds of modeling styles: Dataflow modeling, gate modeling, behavioral modeling, and switch level modeling. Since switch level modeling is rarely used, most of the designers focus only on the first three levels of modeling. In order to have a better understanding, in this presentation I am going to explain that Verilog coding in all the four levels of modeling using 4-in-1 multiplexer. Now let me explain the behavior of this multiplexer. This 4-in-1 multiplexer consists of 4 inputs, 1 selection input and 1 output. When the selection input is 0, 0, the first input A will be selected. When the selection input is 0, 1, the input B will be selected and given to the output. Similarly, C will be selected for the selection input of 1, 0. Finally, D will be selected for the selection input of 1, 1. Here you can see the module declared with the module name mux, which is followed by inputs and outputs. The input I is 3-bit binary value, that is why we have written input 3 down to 0 I. The selection input S is 2-bit binary value and the output O is single-bit binary value. For writing the coding in the Dataflow modeling, we need to know the different operator as well as its operation. That is given in the tabular column. Here the logical diagram and the Verilog program of multiplexer is given. After the module is declared with an input and output port, the output should again be declared in the register. It is a fundamental rule in Verilog. If the program contains always statement, then the output should also be declared in the register. As explained in that animation, the various inputs are connected to output. In the first line of the program, we can see the complemented inputs S of 0 and S of 1, as well as the first input I of 0 is connected to OR gate. Similarly, in the second line, the first selection input S of 0, complemented selection input S of 1, and second input I of 1 is connected to OR gate. In this way, the remaining lines are also connected with OR gate to get the final OR gate output O. Designing circuit using basic logic gate is known as gate level modeling. The basic command of the language defined in Verilog is very easy, so that bigger design block can also be easily designed. The syntax of this gate level program is name of the gate, then the identifier, which is followed by output and input. Another important statement here you should learn is wire. Wire is an intermediate component. A 4-in-1 multiplexer circuit, we have two intermediate components, which are Y and NS. In this circuit, there are two NOT gate, 4 AND gate and 1 OR gate is there. In the first NOT gate, identifier name is N1 and its output is NS of 0 and input is S of 0. And 4 3-input AND gates are there. The first AND gate output is Y of 0 and their inputs are NS of 0, NS1 and I of 0. After the AND gate, we have OR gate. It is a 4-input OR gate. All the AND gate output is connected to the input of OR gate as given in this program. If you write the coding based on the behavior of the circuit, then this kind of modeling is called behavioral modeling. To write the coding in this model, hardware circuit diagram is not required. Here I have tried the 4-in-1 multiplexer using behavioral logic. Here a new term called always block, which gets executed whenever the IP changes its value. If you don't assign that always statement in any of the programs, the change of input will have no effect in the output. Now let me explain the program. The Verilog case statement start with a case keyword and end with the end case keyword. In this case statement, based on the selection input, any one of the input will be assigned to outputs. If the selection input is of 2-bit binary value 00, the output O is I of 0. I of 1 will be assigned to output O when the selection input is 0, 1. Similarly, when the selection input is 1, 0, I of 2 will be assigned to output. If none of the above is given, the final input I of 3 will be assigned to output. Instead of the keyword default, we shall give 1, 1 in the selection input also. Using behavioral modeling, I have tried the decoder also here. Decoder is a combinational circuit that has 2 inputs and 4 outputs. One of these outputs will be active high based on that inputs. If the input is 0, 0, the first output will be active high and the rest of the outputs are 0. If the input is 0, 1, the second output will be active high, and if the input is 1, 0 and 1, 1, the third and final fourth output will be active high respectively. Here you can see that program of 2-in-4 decoder. It is same like a 4-in-1 multiplexer. In this program we can see the if statement for decoder. If the decoder input is 0, 0, the LSB bit is 1, that is decoder output 4 tick B 0, 0, 0, 1. If the decoder input is 0, 1, the output, the second LSB bit is 1, that we can see in that fourth line, decoder out equal 4 tick B 0, 0, 1, 0 and so on. And the case statement for decoder is also given here. Here you can see that full programming using case as well as if statement for decoder. Finally, switch level modeling. This kind of modeling can be implemented in terms of transistors, switches, storage nodes, and the interconnections between them. Since the 4-in-1 multiplexer using switch level modeling is little bit complex, we have tried the 2-in-1 multiplexer. It is almost like a gate level modeling.